And I literally blurted out at him, like after he said it, you know, you're supposed to be like, oh, congrats. And I was like, looks like everybody has my dream job but me. And I was just so, everybody was just like, oh, geez, what the heck is this guy doing? Like I kind of cracked and was just like, oh my God, dude, like I need to do something. And I basically just decided soon after that, because it was kind of like a wake up call that I'm not happy, that I've always wanted to make bikes, and I'm just gonna do it. Like I'm gonna make a bike. And
Evan Turpen, welcome to the Downtime podcast. How's things with you?
It's good. Just real busy trying to catch up with everything.
Yeah, and fair play. We should let the listeners know what time it is in the morning for you, because you've been pretty committed for this episode.
Yeah, it's 5 a.m. here in Aptos, California. But I just wanted it to be on a time that would work for you and still be able to get to the Sea Otter Classic in time to do events today. So
good stuff, man. Yeah, impressive commitment. Well, let's wind the clock back and find a bit out about you and your background before we dig into bike design, which clearly we're going to get into pretty heavily. Tell us a bit about how mountain biking came into your life in the first place, because I think you were you had a mountain bike, but skateboarding was a bit more your thing early doors.
Yeah, for sure. I started off, basically I was kind of a skateboard little punk kid or whatever, and was skateboarding before school. And that was what I would do, just skateboard to school, skateboard outside school until we had to go. And this one day, Jamie Goldman, who basically went on to ride for Santa Cruz Syndicate and stuff, he came wheeling down the road on a Santa Cruz Bullet. And this is like when I was 15. So I think this is maybe like 2000 or 2001. And I was just like, wow, that looks crazy. Like this mountain bike with all the suspension. And I asked him if I could try it out, and I rode it around, and I rode over a speed bump, and I was just like, oh my God, you can't even feel the speed bump. This is insane. and like, that day basically went home, dusted off the Christmas present my parents got for me like years before, which was a rigid Cannondale, I don't know, CAD 3 hardtail with like cantilever brakes.
Yeah.
And just started mountain biking and started saving, because I wanted a Bullet, a Santa Cruz Bullet, but never could save up enough money for that. So ended up just getting like some specialized big hit thing for a couple $1,000, and started racing downhill locally. They used to have a race series near here, and just kind of went from there. Transitioned into racing, and stuck with mountain bikes the whole rest of my life so far.
Nice. Yeah, we'll talk a bit more about the racing side, but I want to just pick into the kind of engineering side of things as well. Was that influence from your father? Is that right? Is he a civil engineer?
He is a civil engineer. So definitely he's an engineer, so he's very detailed. And I think when I was younger, I definitely looked up to how organized and how like professional he was with just any project like around the house and stuff. He, being a civil engineer, he didn't necessarily do the same kind of hands-on stuff like using a manual mill and lathes and things like that. But it kind of, he definitely helped with that mindset. But I think the engineering aspect of it just came from an interest in wanting to go faster on a bike. And like, that was, you're always trying to, change parts on your bike and experience something, upgrade your bike or whatever. And so I was always just from a young age really interested in that stuff, and would make drawings like of bikes and everything. And just kind of self-taught, I guess. So
interesting. Yeah. Nice. And that hunger to kind of make the bike faster obviously worked. Like, your progression through racing was super impressive, right? Just give us a bit of background on how far you went with racing, because you went basically as far as you can go, huh?
I never made it truly as a professional as far as like making a living doing it, but I progressed pretty quickly because all I did was ride my bike when I first got into it. And so from when I started riding bikes and racing locally, like, as like a junior, kind of junior beginner, so to speak, I think it was within like 3 years or so, I had already progressed to be racing at a semi-pro level, which was a category they used to have here. And then kind of won stuff, like kind of didn't win everything that I could win, but I mean, at the end of the year as a semi-pro, I won national champs in Mammoth by like something like 14 seconds and would have placed like top 15 in pro. And so it was like, it was time to move up to pro. And then just kept progressing. And like the following year, I got on the podium at national champs, which was kind of crazy. And then the year after that, I had good enough results to be selected for Worlds to race downhill in Rotorua, New Zealand. So that was 2006.
So 06, yeah.
So that was kind of, to be honest, like that was kind of like the highlight of my downhill racing career. It kind of sucks that it was so long ago, but yeah, to race like world championships and for it to be within 5 years after starting to ride mountain bikes was like pretty amazing for me.
Yeah.
But yeah, I definitely progressed quickly, and then but it never went past, like I never was very good at the marketing yourself side of it and getting sponsors, and I was just more focused on doing my own thing. And
yeah. And it starts to hint at your natural ability to go all in at something. You went as far as, I think you finished school kind of early to focus on racing. Is that right?
So I actually, like, I was a terrible student. It wasn't that I wasn't smart or able to do stuff. It was just, all I wanted to do was ride my mountain bike and like build trails and race. And I would just I would pretty much just sleep in my classes, to be honest, like, because I was just tired from, and I'm sure my parents hated that, and they saw that I just didn't care. So I took the California high school proficiency exam, I think in my second year in high school, and got out of high school early. And the whole stipulation for my parents was that I had to go to the community college. So they're like, oh, we're just like fast forwarding him into, getting a degree, like going to I wanted to go, or if I was going to go anywhere, it was going to be Cal Poly down in San Luis Obispo, which is like a really good engineering school. And they actually have like a bike program. They made a bike for the NABS show, the North American Handmade Bike Show, that was actually like a steel V10 with all this cool stuff. So it would have been cool to do that. But again, I was just focused on racing. So pretty much just like flunking out of all of my classes, and they kind of just realized it wasn't working, and they're like, yeah, you're just gonna have to start working, so
nice. But you did, and at that community college you did some sort of like, was it a 3D design module or something, learning how to use that side of things?
That was like one of the classes that was kind of hilarious, because I do tell people that story that I took it was called Pro Engineer, which is now I think Creo Parametric. So that's like the 3D design. It's actually what I think Fox and Santa Cruz use, is Creo Parametric. And I took this class. You're supposed to be designing, or not designing stuff. You're supposed to be doing these like, making triangles and whatever. And instead I was designing a open bath fork cartridge for a RockShox Boxer. That's actually what I raced semi-pro national champs on, was a fork cartridge that I made, first of all, designed in this class. I got a D in the class, so not passing. But we went and actually, I knew the guys at Gamut USA, so like Juan and Mateo, and they, for people that don't know Gamut, because it does go back a ways, they made chain guides and stuff, and eventually went into handlebars and pedals and stems. But they had a CNC machine in their garage in like near San Jose, and we made this thing in like one day. Like his dad programmed the little valve, like the pistons or whatever. And then we're learning how to use like a lathe and made this damper and raced on it. And yeah, it was because at the time the RockShox Boxer had basically 1970s technology. It was called a damping rod fork, which is like what is used in like a Harley Davidson. Maybe, you know, it's not good suspension. They've obviously come a long way now, but back then they were terrible. So yeah, that was, I guess, my first like bike thing that I actually made real instead of just drawing pictures, which was really cool.
Yeah. And went and won on it, right?
Yeah,
that was the one. Won by a big chunk.
Yeah, I remember. So one of the issues though was that I wasn't an engineer. I didn't understand that you needed to have like anodizing on raw aluminum, especially in a damper. So the oil would get really, like, you obviously would have wear and you'd have like oxidation and stuff that would contaminate your oil. So I remember I was doing a fork service in my hotel room in Mammoth, like, which isn't great. Like, you don't want to spill oil everywhere. Luckily I didn't, you know, spill oil all over the carpet, but yeah, you basically had to like change the oil like every few days because it would just get so dirty from all the wear and tear. You know, I didn't know I had no idea what I was doing, but I knew what I wanted it to feel like. I knew a general idea of how like high-end motocross dampers were configured, how that worked. Yeah. So it was a fun first project for sure.
Definitely, yeah. First dip of the toe into the water. Yeah. So like you said, you struggled, I guess, with the marketing of yourself, and that whole like pro rider career never materialized. Which direction did you go in from a career perspective at that point?
So when I kind of, I don't know, you know, it was always, I would always end up working as like a bike mechanic in the winters, and because that was like the only thing that I was good at, or at least I thought I was good at. And at one point I kind of basically a direction that I ended up going that I thought was quite cool was going and working on basically developing a bike park up in the Sierras, so up in the Sierra Mountains, at a ski resort called China Peak. And that came about kind of randomly. And I spent a couple summers up there building trails and helping host events. I actually started the China Peak Enduro, which is part of the California Enduro series. It's actually one of the stops that they've had like every year for, I think it's like going on 7 or 8 years. But that was also a big learning experience too. Had timing issues and stuff because none of that was figured out with enduro, and it was hard to do. But yeah, so I went down this path of like trying to help build a riding spot, like a lift access riding zone, but it was difficult because we had like no budget. They're super small. So I did that, and then I actually ended up meeting my now wife up there, Margot, which was pretty interesting. And then went on to work as basically a bike mechanic again. On top of trying to race enduro races, that was another thing that I got interested in, and did some EWS races. Thought I was going to become a pro there. Actually was able to get offers for support, like a financial support, not enough to live off of or anything, but which was interesting. But yeah, just mostly just worked as a bike mechanic. So I've always seen what's bad with bikes, what's not durable, what's good with bikes, obviously, as well. So yeah, just working on bikes almost my whole life, and then eventually
a super good background though, right? If you're going to design your own, spending time hands-on with so many other bikes is a really good start. Like you say, learning what's good and what's bad.
Yeah, for sure. I mean, it wasn't like I was riding every customer's bike that comes in. I mean, you do test ride bikes and stuff. And for a short while, I was also doing some reviews for Vital MTB like a long time ago.
Okay.
Was reviewing products and stuff just for fun, and that was something that I really enjoyed. Was like we did the like a sort of a field test thing, or well, it's called the test sessions, I think, and got to ride like 8 different enduro bikes or something like that over a week, and just seeing like how like it was at the time when 29ers were just like starting to come into the mix, and it was just really interesting riding all the different bikes and trying to figure out what was awesome and what wasn't. And yeah, but kind of just honestly just kind of floated through life trying to figure out what I wanted to do, and eventually settled on this bike thing. So
yeah, so how do we get from bike mechanic then to going all in and having a go at starting your own bike brand? Tell us a bit about the background.
Yeah, so I'd always been like, over the last probably maybe 10 plus years, I'd always been playing around in the linkage design, which is a little software you can get that basically you can analyze suspension designs. I'm sure some people use that or know about it. But that was a simple way to start to look at bikes that I had been riding and try to figure out why they felt a certain way, and like what, you know, if I liked something about a bike or I didn't like something, what was that actually when you're looking on a graph or whatever.
Yeah.
So I'd always been interested in that, and I'd always been playing around, like trying to design my own kinematics, my own linkages and stuff, and achieve something. But I never really, like, it never really went any further than that. And it took working at a bike shop for too long, to the point where I was just kind of, I wasn't happy. I was quite frustrated, not with the shop that I was working at, but just I wasn't really going anywhere, you know, like I wasn't able to really progress as a professional, as like as a career. And yeah, just one day I met my now wife for lunch at this like sandwich shop in the middle of the workday, and one of my friends or coworkers that I'd worked with before at a bike shop was there, and was like, had just started a job working like in the engineering department at Fox Racing Shocks, because they were right around the corner. And I literally blurted out at him, like after he said it, you know, you're supposed to be like, oh, congrats. And I was like, looks like everybody has my dream job but me. And I was just so, everybody was just like, oh, geez, what the heck is this guy doing? Like I kind of cracked and was just like, oh my God, dude, like I need to do something. And I basically just decided soon after that, because it was kind of like a wake up call that I'm not happy, that I've always wanted to make bikes, and I'm just gonna do it. Like I'm gonna make a bike. And I don't know if I thought at that moment that I was gonna actually try to turn it into a company, but I needed to do something different. So yeah, at that moment, then I ended up just like figuring out, how am I gonna do this? How am I gonna be able to quit my job? And so I went to like the bank and took out a personal loan to try to cover living expenses for a little while and have some money to create a prototype. And yeah, it just kind of started there. And that was, I think, towards the end of 2019. So it was like kind of interesting. I think it was like October. Yeah, was like my last day probably at the bike shop. And then
just before COVID.
Yeah, just before COVID. And I also, I think a lot of the time spent too, I had a broken kneecap from a bike race. So I hit a tree racing an enduro race with like a little thin knee pad. I think it was like a G-form knee pad, which I'm sure they have thicker pads now, but the ones that I had then were quite thin, and just broke my kneecap. Luckily, it wasn't like straight down the middle. But so I was off the bike and didn't know if I would be even, I mean, that might have been, I can't remember exactly when that happened, but yeah, I was definitely not back to riding for quite a while. So it helped designing stuff during that time period. It helped
Yeah,
keep me
plenty of time on
busy.
your hands. Yeah, definitely.
Yeah.
Well, so you've quit work, you've managed to get some money from the bank. Where do you start with the bike? Because you've got a little bit of experience by the sounds of it in some sort of CNC stuff, some design, a little bit of 3D CAD background, but not a huge amount of experience. Where do we go from here?
Yeah. So the first thing, obviously, like the easiest thing for me was to focus on the kinematics and using linkage design to try to figure out like a direction to go with the bike. And I didn't want to just make a bike that is the same as everything else. And it's not that you can't make a good bike using like a normal linkage design or whatever, but I was kind of searching. I like had this list, like this checklist of, I want it to do this. I want it to do this. I want it, like, just the little kind of dream checklist of what I want in a bike. Yeah. And so it started with trying to figure out like linkage designs and what direction to go. And at the time, my buddy, I don't know if I should, I guess he's not going to get in trouble or anything, but Kieran McKinnon is like a good friend of mine. And he is actually kind of, I think you've had him on the podcast before.
Yeah.
And he's at Santa Cruz, and he's doing a lot of development on bikes and testing and stuff. And at the time they always had a lot of bikes at Santa Cruz, like different bikes. And I got to test ride one of their bikes from the engineering department, which was a Commensal Supreme SX, which was like like a free ride bike, to be honest, but a high pivot with an idler. And I went on a ride. I borrowed it for a while and was blown away by how smooth it was in rough sections. I was like, this feels better than any downhill bike I've ever ridden through rough sections. There were tons of other problems with that bike. And things that I didn't like, things that I learned from it, like the drag from the small idler, like inefficient pedaling, really high brake squat, which I didn't like. So going into for people that don't know, like just the influence of like your brake torque on the swing arm on a high pivot bike. If it's a high single pivot, it can basically almost create like violent squatting into the travel. So that was really something I didn't like. And the pedaling, obviously I didn't like, but I loved how it was in the rough. And that was something that really stuck in my mind, was like, wow, this is really very different and quite cool. And that was obviously, I think at the time, Commensal had kind of been dominating the World Cup downhill using their high pivot bike, and that was kind of the new hot thing that was going to happen. But there wasn't much of anything on the market at the time. I think Forbidden was maybe kind of the first major high pivot bike that was like accepted by the masses. So that definitely, I don't think that swayed my decision to go towards a high pivot bike, but it definitely didn't hurt it. It seemed like people were really interested in it. But yeah, again, I was creating the bike for my dream bike, not necessarily like, oh, what does the customer want? And yeah, I learned that I could do some really cool stuff with a high pivot. You just have some kinematics you can achieve that you can't with a low pivot, or at least I don't think you can with a low pivot or normal drivetrain. So from there, thought that I needed, since I didn't really know how to do 3D design proficiently, it'd been a long time. I thought I needed to hire somebody, like a friend who was they were an industrial designer, and so they had access to SolidWorks, and I gave them the kind of kinematics and the pivot locations, and he started working on trying to create it and make it into a bike. But at the same time, he wasn't really super experienced with like doing that, and so it was taking a while. I didn't have like a budget to go pay some, an actual design engineer to do this thing. So he was working on it, and progress was kind of slow. And I'm like, you know what? I'm gonna just see if I can get like a student version of Creo Parametric, which was the same as Pro Engineer, because I had used it in the past. And so I somehow got a student version of Creo Parametric, taught myself how to use it in about like a week or two, watching like YouTube videos, like a whole series, and then started designing stuff and got to a point where I was like, yeah, I can do this. Like I can make this work. And,
Yeah.
and actually to rewind back a tiny amount too, well, I guess it wouldn't be rewinding back, but from there I was, I'm like, okay, I'm going to design this thing, but then how am I going to make it? And that was the other big thing was I got a bike designed and then it was like, I don't have the skills to make this yet. So I then looked at outsourcing that. I actually talked with Brent Foes at Foes Racing down in Southern California. And at the time, I think he quoted me something like 15 grand to make 5 frames, but I would have to provide all the CNC machine parts, which is like a huge expense. And I'm like, I can't afford, like at the time I was like, oh my God, that's so much money. Now I'm like, oh, I would have done that in a heartbeat. Like to have somebody that good make me 5 frames for that amount. Like it sounds like a huge amount of money, which it for 5 bike frames. But, and on top of that, obviously all the CNC parts would have been probably in the range of 7 grand to be made here, which is what I wanted to do. I didn't want to, order stuff from overseas. I wanted to have a relationship with the person making it and be able to communicate well. So yeah, that kind of ended up being a no-go. I was like, okay, well now I'm going to have to figure out how to make this. And I felt kind of stuck because I didn't have any machinery. I didn't have the experience. And luckily, I don't know, through probably just talking about it, what I was trying to do. This guy, Bjorn, who he basically, he's an engineer, he's a mechanical engineer and also a huge like mountain biker. Like he's into downhill racing and all this stuff. He was like, hey, like we have this shop down in Watsonville and we've got some tools and like, you're welcome to come in and like check it out and try, like see if you need a space to try to make a bike or make parts, like you can use the shop. And so, I kind of just decided, I'm like, okay, well I need to learn how to do this stuff. I might as well hit him up. So I went and checked out the shop and he showed me, how to use a lathe and how to use his mill that he had. And basically really, I was probably really cautious at first and he realized I wasn't gonna rip my arm off and was just like, cool, all right, yeah, so you can use the shop if you want. And so that was huge, because if anybody has ever looked into getting like manual mill or a lathe, like obviously you can probably get some used ones for not that expensive, but it's more having the space and bigger thing is like transporting it to get it there. Cause a lot of these things are so heavy, a Bridgeport mill is, I think, well over a couple thousand pounds. So it has to be like trucked and like forklifted in, and you have to have, 220 or whatever. You have to have, the electricity for it and everything. So, just started working on, again, watching like YouTube videos of how to miter bike frames and watching anything and everything I could to try to teach myself how to make a bike. And
awesome. Yeah,
it just went from there.
Yeah. What was the trickiest part then of getting that first prototype together?
Everything was hard, but I think for me it was like certain machine parts that I designed, because I was designing stuff in 3D, but I didn't have an understanding of like what it meant to actually make that. So I tried to design stuff as simple as I could, but some of the things that I had designed had like crazy tolerance stack-ups where like all these things had to be absolutely perfect, otherwise it wouldn't work. So on the first bike that I made, which was a high single pivot with a linkage, and it was actually concentric. Part of the linkage was concentric to the bottom bracket. So I was creating this whole like bottom bracket shell that was like a huge axle that was actually press fit into the frame. You like threaded it together almost like those, I don't know, Praxis Works I think makes a bottom bracket for like BB30 bikes or something that you can like thread together and then it press fits in. And so like that thing I think took me like 2 days making this part because there were so many steps to make it. Like I bought like taps from the UK because like you couldn't do they call it the UK anymore? I don't know what to ever call it. Okay. And because it's like English, you know, English bottom bracket taps. So I was like, I have to be able to tap this. And just making that complex part was probably one of the most nerve-wracking things. And then also I did everything like the hard way on the first bike. Just all the steel parts that were like plate parts, instead of getting them laser cut, which is what I now do, I literally was cutting everything out with a jigsaw, like from a template. And the first bike had these like huge, it needed these huge gussets to keep the frame from basically spreading apart, because I didn't really understand FEA or anything. And so my buddy kind of pointed out, that I
just explain FEA quickly for people that might not be familiar with the acronym.
So finite element analysis, which basically you take a 3D design and it, you know, virtually you basically can stress it in a way, however you define the way that you're stressing it, so you can apply a load and see whether or not the material is going to hold up, at least if you understand things correctly. And I just had no understanding of like what the actual forces are going into the pivots of a bike. And luckily on the newer linkage design, they have a professional version. You can actually quite easily put a spring rate on the bike and bottom the bike out virtually, and you can see where all the forces go and how they are. And that was really a big part, was like looking at these forces and how they go into the bike and being like, is that going to work, or is that going to try to break the bike apart? And so once you know what those forces are roughly, the way I was doing it originally was just looking at the directions of those forces, precisely getting the force and the direction, and then like just kind of like holding a frame in virtual space and loading it in those directions. So it wasn't necessarily the most accurate way to do it, but it gave me a good starting point. And the first bike would have for sure, like over time, it would have 100% failed from like hard bottom outs and stuff. And so instead I ended up putting these like huge, it added like 500 grams to the frame to put these huge gussets that basically tied in the main pivot to the shock mount. So those two things were trying to pull apart, and now it was just a tensioned piece, and basically it was completely fine after that. But making those things, you know, cutting out these huge plates, precisely bending them, like literally just bending them in a vise, like with a hammer, and then drilling out all the holes precisely on a mill, like building a fixture to hold that bent part, and then mitering everything. Like, I guess that was quite a hard part as well. And I definitely did everything the hard way. So it's nice to have progressed a little bit beyond that to where I'm still doing things the hard way, but it's getting easier as you learn more, for sure. But I would say
it must have felt amazing though to get that first one done and build a bike from it. That must have felt so good.
Yeah, that was definitely, I can still remember like just the first day, like kind of riding that thing. We wanted to take photos obviously before it got super dirty and but just riding it around and being like, wow, it actually does what I set out to do. But it was also very interesting riding it for the first time on a trail, and then being like, wow, this is way different. And certain things, you know, you're just like, this is amazing. Like this does stuff way better than anything I've ever ridden before. But then also there were other things where you're like, it's a little weird how this works. Like I've never ridden a bike that feels this way, and you couldn't quite pinpoint whether that was good or bad. And so it took a while.
Did you find it hard to be objective with it? Like, because it's your baby, like, was it hard to criticize it off from the start?
Right away. Like, I mean, the thing is, the first bike kinematically was pretty good, and actually it's not, you know, exactly the same as what I'm making now, but it had a lot of similarities. And so yeah, it probably did take a while of having to ride it so that kind of honeymoon period wore off, and I could start to look at the bike and pick apart what I didn't like. And you know, obviously the complexity of making the bike, that was a kind of a very complicated bike. It didn't have it couldn't have like shorter chainstays really than what it was, which I know isn't that important now. People like really long chainstay, or at least that seems the direction that the industry is going, is longer chainstays. But I also was like, well, what if I want to make a small bike, like for somebody that's a lot shorter? They're not going to want a super long chainstay. And then it was also, you know, it was pretty expensive to make because it had some like big machined parts. Like one of the lower links was this big one piece of 7075 aluminum, and was quite expensive to make. There were just like a lot of things where it would be hard to actually produce that, and there wasn't like I felt like there could be a better way of doing it that would be easier to make, lighter weight, stiffer in the right direction. And then a big thing was reducing the unsprung weight, because the swing arm on that first bike was massive. It was really heavy. It was like 1,600 grams for just the swing arm. And like, to compare that, you know, I've weighed like a Santa Cruz trail bike swing arm, which obviously isn't the same intended use, but I think they're in the like 700 gram range. So, okay, you know, to have that much extra weight, that was one thing that I learned, is that even if you have a high pivot bike that can take a square edge hit a little bit better because it's moving in the direction of the bump, if you have a huge amount of weight, it will actually kind of choke up the suspension, because you have to move all that weight. So if you think of like holding your arm out and like moving it up and down really fast, and then holding your arm out with like a 5 or 10 pound weight and trying to move it up and down really fast, it's a lot harder to react. So
slowing it down and speeding it up is a lot harder, right? That change of direction of the suspension is a lot harder.
And it adds like initial harshness, and then when you do hit that bump and it's finally, your wheel is accelerating upwards, when it gets to the top of the bump, you want to try to keep your wheel stuck to the ground as much as you can. And instead, because it has so much mass, it just continues to go, and you have to use your damper, but like you can't add too much damping because then there's harshness. And so, yeah, a big thing from that first bike to trying to figure out the second bike was for sure reducing unsprung weight. And then the braking characteristics on the first bike was also a little interesting, because I had like, in my mind, I thought having it be 100% anti-rise, which basically means when you hit your brakes, theoretically, there's going to be no movement of the suspension from like your weight shifting forwards. I guess maybe that's a good way of describing it. I'm not. People might think that means the suspension is locked out, and it's not necessarily locked out. It's just, if you think of a car like braking really hard and how it tilts forwards, it basically just meant that when you hit the brakes, it didn't really want to tilt forwards. It would just stay level. And like other high pivot bikes, if you hit the brakes hard, they actually dive down on the back end from the brake torque. Not all of them, like they're very different now, but so that was actually really weird, because you would go to brake into a section, like into a corner or something, and you would like move your weight back because you're expecting it to tilt forwards, and instead the bike would get slacker, and you're like, oh wait, okay, I need to stay in the same spot when I'm braking. It was like really hard. That was something that was like the one thing that, right away I had another friend ride the bike, and right away he was like, the bike's really fast, but he's like, I can't quite wrap my head around like the braking. It's not bad. It's just weird. Like I don't understand it. And so, yeah, I kind of learned through, I guess, in like power sports, automotive stuff, like race cars, you want a little bit of chassis like geometry change when you brake hard, because it helps your brain to like understand what's going on. And also, obviously, a little bit of it diving into the fork travel is going to help initiate a turn. It's going to like help the geometry of the bike and weight the front end naturally. So that was another big thing that I focused on improving.
Okay, so yeah, back to the drawing board then for some refinements, I guess. And the biggest change, it appears, was from a linkage-driven single pivot to what is basically a VPP with counter-rotating links. Is that right?
Yeah, I mean, I guess VPP is Santa Cruz. That's their term, but in a sense, I mean, that patent's expired now, so I mean, I don't.
Yeah,
it's kind of similar concept to how the Horst link, which used to be Specialized for so long, is now kind of open source and everybody can do whatever they want with it, and that's why a huge amount of the bike industry went that way, because that's a great linkage, or I guess it's a linkage design, but it's quite long links. And so it was really funny because I was trying to make a bike that did everything that I wanted, that improved those things, improved the packaging, improved the kinematics. And so I went down a whole bunch of routes, and for whatever reason, I was like, oh, definitely not like VPP style bike, counter rotating links, because of, I don't know, I just didn't think it could do what I needed it to do. And so I went down the route of like a dual, like co-rotating links, like similar to DW Link. And I actually was talking with Hugh McClay, who is at iTrack, or he started iTrack, which is basically, he patented an idler that's moving. So basically, if it's on a linkage member, or if it's on like a Horst Link bike and it's mounted on the chainstay, which isn't physically connected to the rear wheel, so it's moving at like a different arc compared to the rear wheel, then that falls under his patent. So I was like, I had designed this bike that I was like, oh yeah, this is going to be great, whatever. And then talking with him, he's like, yeah, that, I'd gone far along designing this thing. And he's like, that probably infringes on DW Link. And so I was like, crap, I have to start over again. And so then I went to like a Horst Link style, so the FSR or whatever you want to call it, and was able to get a pretty good layout with that. But there were a lot of limitations that, areas where I was running into issues and couldn't quite make it the way I wanted it to. And then through chance, I don't know why, I kind of just started playing around with VPP style, like counter rotating links, and tried to create the kinematics that I was shooting for, and like just magically was like, wow, this could actually work. Like this could actually do everything that I want it to do, and package it in a similar way as well. So, and because the patent is expired, I was like, well, hopefully I'm not going to get sued by Santa Cruz or something for doing this. So yeah, that was quite a long process of designing a bike, thinking it was like fully baked and like ready to go, and then being like, oh, there's like a major issue here or a major issue there. Can't do that. And it took a really long time. I can't remember how many hours I was spending on linkage design. I mean, it was probably months of just moving pivots around and trying to achieve what I wanted to. So yeah, getting to this, what is now basically the design, which is counter rotating links. It's kind of similar, to be entirely honest, like it's not the same layout as a propane, but it's very similar in that the shock is vertically oriented and the linkages are in front of the shock. But it's, outside of that, it's actually, the kinematics are quite a bit different. They don't make a high pivot version of their bikes yet, to the best of my knowledge. And the other thing too with this newer layout and what I'm selling is that the forces going into the bike are really good. And so the pivot forces on a normal Santa Cruz bike, like where it has that lower link or VPP bike, and it's pushing the shock like forwards into the down tube, you get a really high load on that lower link, which luckily it's like a strong area of the bike and you can deal with that. But then you also have like a load on the top tube from that upper link, and that's just kind of floating in space. So that's not as high of a force, but it does require some reinforcement to be strong. So the cool thing about this layout is where you have a shock pushing up into the top tube, and then at the same time you have a link pulling down on the top tube. So when I started doing FEA on that setup, I learned that it was very strong and didn't need to be reinforced drastically in order to take high loads, because they had kind of these opposite loads that countered each other. So, and then also the way that it puts force into the lower link where it compresses the shock was actually really good. It was drastically reduced, and it was not totally in line with the down tube, but if you think of like the stronger direction for a tube is definitely like in tension. So it was basically pulling on the down tube, and it was a much lower force than anything else. So all of a sudden the bike didn't need to be drastically overbuilt to take a huge impact. Like you could, it hasn't been to Rampage yet, but like you theoretically could go and send a 40-foot drop or something and hopefully not land flat and break your ankles. But like I wouldn't be scared of the bike ripping itself apart from that. So
yeah. And some secondary benefits of that layout as well, I guess, like you've got plenty of space for a water bottle, which is really important for people now. And you've got that uninterrupted seat tube, which is awesome for getting super long droppers in there.
Yeah. And that's also, that was one of when I wrote my dream list, like at the very beginning of this, it was like, I want an uninterrupted seat tube, but also having it, actually the seat tubes originate at the bottom bracket, like how hardtails were or whatever. Whatever your seat tube angle is what it is. So on a normal bike, you have to shift the seat tube forwards from the bottom bracket, and then it's tilted back at basically to create the clearance, because now we have like 29-inch wheels. There's no clearance. Everything that's part of why maybe the industry is going towards longer chainstays too, is just to create more breathing room and the ability to create some geometry that they want. But the thing I didn't like, and the thing a lot of riders didn't like, is with that setup, when you have a tilted back seat angle, because you're trying to like intercept this one point floating in space that is the right point for pedaling, that only worked at that perfect height. If you're taller, all of a sudden you have a way slacker seat tube angle, and if you're shorter, you have a way steeper seat tube angle. And some of these bikes with really slack seat tube angles still had clearance issues. I know there were some issues where tires were bottoming out on seat tubes still and bottoming out on the seat. So part of the benefit of a high pivot bike as well is just the wheel moves up and back quite a bit out of the way. So you can get away with a really long travel dropper post. You can have the seat where you want it and not have it buzz. And even like I just built some small trail bike frames, and we put like at a fairly low saddle height, with a 213 mil dropper dropped all the way, and you could completely. So this is a 370 mil length seat tube, which is quite short. I think that's usually a small or an extra small from most frame or most major manufacturers. And you could have the seat basically fully slammed, and the tire won't hit at bottom out, which is like for shorter riders. People buzz their tire on their seat all the time. So that was a big benefit as well, is just getting extra clearance there. For shorter riders and even for taller riders, I guess. So
nice. Yeah. And why steel? Was steel always part of your list from the start, or is steel something you decided on along the way?
It was definitely something I decided on along the way. So I think originally I was pretty set on making the frame out of aluminum, because I felt that it could be lighter, which it definitely could be lighter if you do it right. But part of the issue is that there's not as many, at least if you're in the US trying to source tubes, there's not as many options for proper tubes made out of aluminum. Like you have kind of one place that has like a few different size chainstay extrusions. I think it's called fairing, and they, so there was only like a few tubes that I could choose from, or I would have to get something like pay for tooling to get something custom made, which would be quite expensive. And then you also have the issue of you have to heat treat it after welding, which isn't like, obviously it's not an issue for major bike brands. They do that. But part of the issue with that is that when you go to heat treat something, basically you're baking it, you're getting it up to a really high temperature, and then I think you drop it in oil, like you quench it or whatever, which basically puts it in this soft state where you can align everything. You can like get the frame to be straight. Because when you weld a frame, and I think on an aluminum frame, it's even more exaggerated, you get a lot of distortion because you're completely making everything liquid, and then when those welds cool, it's going to pull in a certain way. And if they haven't welded it in the right way, or your miters, like the way that you cope the tubes together isn't tight, you're going to have a lot of geometry change. So I remember hearing stuff through the murmurs through the bike industry, like, oh yeah, there can be like plus or minus like 1.5 degrees on head angle, like between frames and stuff. And you're just like, what the heck? Like, that's a big difference. Like, and I knew on my bike too, like if my pivot locations don't stay very close to what they're supposed to be, the bike's not going to work the way I designed it. So aluminum was like, I went down a route of looking at doing aluminum, and I looked at tons of different things. And then I was like, oh, I'm going to like create lugs and like bond it together and do all this stuff, because there'd be no heat, and that's a cool thing, but it's very expensive to do. And also like, I didn't necessarily understand how to bond things together appropriately. So I kind of felt stuck for a while there. And steel, I knew that steel was a little bit more forgiving in certain aspects, that it didn't necessarily require heat treatment after welding in order to ride it. So for me, I was like, oh, that's a plus, that it's not going to get all warped being heat treated. And then it looked like there, basically a lot of people in this area, custom frame builders, would have the ability to do the welding, because that was the other thing, is being able to find somebody that could weld it and know how to weld a bike properly. And then as I learned more, I learned that, there's massive amounts of tubing available. You have Reynolds, obviously, you have fairing, which had a whole bunch of cool like butted tubing and stuff, and they have like formed chain stays, and there's just a lot more available in steel. And also that was an issue because during COVID, there was like, that was a concern, was like, what if I go down this route and then I can't get, if I go down the aluminum route and I can't get the chainstays that I need, like I can't make a bike. And with steel, it was like, yeah, you can take like a normal chromoly tube, you can get them in crazy different amounts of wall thicknesses, and you can bend and form it and not need to heat treat it I mean, obviously it would be beneficial if every tube was heat treated before, or it could be beneficial, but the reality is that custom frame builders have been doing it that way for quite a long time, and it's fine and it's strong. And that was the other benefit, is learning that once I had a little bit more understanding of like not the chemical properties, but like the structural physical properties of materials, steel is just really good for fatigue. So yeah, basically any stress below a certain level, it can basically take infinite amounts of that, like infinite times, infinite cycles. And with aluminum, like basically any amount of stress is taking life off of that frame, no matter how small it is. I mean, granted, it might take forever if you're just touching the frame with your finger or something, but over time, theoretically, that frame will fail from just the accumulation of stress. So that was a big thing. And then through kind of a chance meeting, I ended up going to this party at John Coletti's shop. So people that don't know who he is, he's a custom frame builder in Santa Cruz. He makes high-end, like titanium, mostly titanium, like road, gravel, cross-country bikes. And he also does steel. And so I got to see his shop, which is awesome. It's this like work, live space. And it's like a dream shop. And I ended up talking to him probably after a few drinks and just was like, hey man, I'm trying to do this. And like, just was kind of like throwing a Hail Mary, like, would you be down to help me, weld this frame? I wasn't asking for him to make the frame, and so that's kind of where it came about, is I needed to figure out a way locally to make the bikes. And then also just with steel, it was more the availability of tubing, the ability to form it, not needing to heat treat it, and just being a way that I could do it and I could make these here. So, and that's kind of why I ended up on that. And I've actually, I mean, I wouldn't say that there's I know a lot of people are like, oh, it's this magical material, and it's a great material. The cool thing about it is it's quite stiff in a more compact package. So when people look at a frame and they're like, oh, those tubes are so small, you're like, yeah, but that material is 3 times as stiff as aluminum, like, or generally around there. So my bike only has 3/4 inch diameter chainstays and seat stays, and everybody looks at it and is like, wow, that back end's got to be super flexy or whatever. And it's not, because it's way stiffer. If you made that same chainstay in aluminum, even in like a decent wall thickness, they would be completely flimsy. But so that was a big benefit, is just creating more clearances as well with steel, giving you more room. Like having smaller tubes gives you more room for everything, which is really nice. Any frame designer will tell you that they struggle to have clearances. I guess maybe it's not so difficult in carbon because you can just make whatever shape you want, but for the most part.
Yeah, true. But you've paired that steel frame in all the builds I've seen anyway with WeAre1's carbon wheels, which is the same direction I've gone. I ride a steel bike with WeAre1 wheels on. Is there a reason that you chose that product specifically to kind of go with the bike?
Yeah, I mean, A big part of it is just like I really like what they're doing up there in Kamloops. Like I think Dustin at We Are One is like pretty awesome dude, and like it's cool that they're like we can make these carbon wheels here and do them better than anybody else. And I truly feel like I bought a set of their wheels for like my show bike, like one of the bikes that I made for Sea Otter, and I hadn't ridden them yet at that point, and then I just started riding them, and like the benefit of having that wheel paired with a steel bike, I don't know, it just, the ride is like the flex is in all the right places, and also obviously as long as you're not smashing it super hard into rocks, like you're not really gonna have to touch them. And then for me, like going beyond that, so that was the Union wheels that that I bought first from them. And then when I was building a bike up to go off for the Pink Bike field test review, Dustin had those new prototype wheels at the following Sea Otter, what ended up being the Convergence rims. And I was like, man, it'd be really cool to like have those wheels on the test bike that's going to Pink Bike. And like I hadn't ridden them yet, but I know that what they're doing is like they're pushing it, you know? And so yeah, we got those wheels like just in time for the Pink Bike review bike, and then I've been riding those ever since, and giving them feedback on those rims, and I've just been like blown away with. The first ride on them was up at North Star Bike Park, which is in Tahoe. It's very rocky. They had the EWS there, and I was riding like no inserts. They were on downhill tires, and it's just like just crazy how you can like. For me, I was able to, I mean, I don't know. I know there's people that will still break carbon rims, but like I was on purpose, like hitting rocks and like hitting the rims. And it was just kind of like a dull thud when you'd hit the rim. And usually if you like rim out, like if you hit your rim really hard, especially on like an aluminum wheel or a stiffer carbon wheel, like too stiff vertically wheel, it's very harsh. And so this just added to like the ride of the bike. For sure. But, you know, I have ridden the bike with aluminum wheels as well, and it still rides good. You just are going to have to do more maintenance, and you're probably going to have to replace that rim after you smash it into rocks a bunch of times. So, yeah, but definitely, you know, most of the customers that are buying this bike, it is a quite high-end bike. So they're doing their dream builds, and they're going to put whatever they want on, and hopefully some of them will get those wheels.
Nice. So you've got a bike then, I guess, that you're happy with, right? This counter rotating virtual pivot style, all the improvements to reduce unsprung mass, etc., etc. How do you go then from having a bike in prototype format that you like to creating a bike company? Because there's still two pretty different things.
Yeah, for sure. Like making a prototype, you're just making it for you, so it can have quirks or like things that are weird, and be fine. But making it for a customer, you now have to make a bunch of different sizes, which luckily, like, you know, it's not carbon mold, so I'm not paying for the tooling for that. But you still have to design every frame size and all the clearances, and figure out what those frame sizes are going to be, and do simulations on those structurally to make sure that like a different frame size isn't going to need a different tube set or a different gusset or whatever. And so that took quite a while, especially because I went down the route of making size specific chainstays, and I do it in a way, since I can't really shift the pivot locations around to do that. Like most companies will just shift or you could look at it as they shift the bottom bracket location. But realistically, that's a great way of doing size specific chainstays from like a manufacturing perspective, because you can have just one back end that's the same on every bike, but you can have all these different chainstay links. You could also do like a flip chip thing. I think Raw does that. Theirs is pretty clean. But I think that creates some complication with the SRAM universal derailleur hanger, which I kind of knew that was going to be the way going forwards. So doing like a flip chip thing on the chainstays, also that adds a lot of weight. Like when you start doing a flip chip thing on a steel frame, or you do like sliding dropouts, you're just adding a lot of weight. And the whole point was to reduce unsprung weight. So, creating all the tooling for the frame, like just adjustable chainstay links and all different head tube positions to create the different reach and everything. That took a while to figure out. But more so what has taken a really long time was that I wanted to be able to bend the steel tubes to a higher quality, but also to a more extreme geometry to create more clearance. So for most custom frame builders, they'll use, well, I mean, there's a few tubing benders out there. There's one that's like called the Cobra tubing bender. This guy makes some frame building tools and he makes a tubing bender. And that's what I used on the prototypes. A friend had one of those. But it has its limitations on what it can do. So I basically designed my own tubing bender from the ground up that is a mandrel tubing bender. And so people that don't know what that is, basically when you're bending the tube, instead of it just being the tube getting bent, you have the tube getting bent with a support inside of it to keep it from distorting. And so like that's the appropriate way, I think, to bend a tube and get a really good quality of the bend and be able to do a tighter radius so that you can create more clearances. And that, I think I just didn't understand how complicated that would be to design and build. And I think I was like, oh yeah, it'll take me like a couple weeks and then we'll have, my machinist will make the parts that I can't make by hand. And it was like at least 2 months of making this tool. And even after making it, then it was probably another 3 weeks of like having to dial it in because certain things I'd never made a tube bender before. I didn't understand the kind of forces going into it. I knew that the forces were high, but there were lots of modifications that had to be done to get the tubing bender up and running. And so that's all super good now. We're getting really good quality of bends. And going from there, also sourcing all the material, like placing the order for all the CNC parts. That's kind of nerve-wracking when you're like handing over tens of thousands of dollars. And that's the other thing too, is people probably don't know like how this is funded. Like I don't have I didn't go out and get I guess technically it's somebody else's money, but we basically refinanced our house to pull cash out because we couldn't figure out a good way to get the funding. Like I had tried to get funding through friends, just through whatever means, and I couldn't figure out a way to come up with enough money to go to production. So luckily our house had appreciated enough that we could pull cash out. But it still wasn't enough technically. Like I knew it wasn't going to be enough. So even though I was kind of originally I was very against having pre-orders for bike frames, I was like, okay, we're going to also do pre-orders because that will help with, people pay $800 up front and that helps go towards making the bike, the costs of making it, because it was really high. And that is the other thing too, is like, there's that whole financial side of it that you have to figure out how you're going to pay for all this stuff. Because it's not just like, it's not small amount of money. Even making, 30 frames, it's not a small amount of money just to buy all the materials and to get to get set up. And you know, I don't really pay for the workspace. Like, luckily Bjorn and his dad are still happy having me be there and like helping me do this, because there's no way that I would have, if I had to buy all the tooling and stuff up front and you know, the machines and have a space, like this would be very different, and it probably would take even longer than it's already taking. So, but yeah, getting it through to production has been interesting. Yeah, I ended up running into a big issue too when I was trying to make the SRAM universal derailleur hanger dropouts, and I designed them there was a moment where I didn't have access to FEA, the simulation software. And that was like the one thing that I was designing, these dropouts, and wasn't able to virtually test them. And we ended up pulling the trigger and making these dropouts because you just think, oh, they look similar, they're going to be fine. And when I started testing them virtually, which happened after we had made them, I was like, these aren't going to pass the tests. They aren't going to pass what I want it to do. And like, for instance, those dropouts are very expensive. They're made here. They're quite complex. They have a lot of tolerances. And yeah, that was like $5,000 or $6,000 just gone in dropouts that, I mean, maybe I can use them on a lightweight cross country bike or something if I ever make that. But, for the intended use of the bike, they weren't gonna work. So had to start over, and that set things back a little bit, redesigning dropouts, remaking all the dropouts, and just running into issues, other things where like parts from certain manufacturers would come and they wouldn't be to spec. And this is all stuff made in the US. Luckily my machinist here is super dialed. Dave Mather of Mather Machining, which is like just up the road. He used to make parts for RockShox when they were here, like the very first Boxer. You go in there and there's the Boxer crowns. Like, he made all those for RockShox when they were here, like in 97 or 98. So it's kind of crazy to think that the stuff that he made in that shop was like on World Cup overall and like world championship bikes back in the day. And he's really good. He's been a huge help. And he's also kind of like helped me learn what is and isn't important, and where can you loosen a tolerance and still have the part be the way that you need it to be. Because I think at first when I designed everything, that was the other thing too, is just learning about tolerancing of how do you what like dimensional limits do you put on something when it's being manufactured? Because at first I was like, my buddy asked me, he works at Fox, he's a design engineer, Fox Racing Shocks, and he's like, so yeah, like what kind of tolerances do you have on this? And I'm like, oh, I just give them like the parts file and they just make it. And he's like, no. He's like, nope. You have to have it. And I like, that's just the thing. You don't know until you know. And I didn't know that was a thing. And learning. So at first I would be like, oh my gosh, it has to be plus or minus 0.1 of a millimeter or something, or like 0.01, of a millimeter, not 0.1. And people are like, yeah, we can't do that. Like, that's not realistic. Like, and so then you're like, okay, 0.02 of a millimeter. And you're like, but you can't just like generally put a tolerance on every single thing, because there's a bunch of dimensions that aren't critical that can have it
would cost a fortune.
Yeah. And you don't need it to be as tight. And that sounds bad, but there's certain things on a bike areas where I feel like you have to be very tight with tolerances. Like bearing bores where bearings are pressed in, they need to be a very tight range, like plus or minus 0.02 of a millimeter, which is like less than 1/1000th of an inch each direction. For it to be like the way that you want it to be. And it is crazy when you start like putting calipers and taking dimensions off of frames that exist out there, and you're like, whoa, like they create a lot of space like around pivots and things like, and by space, I mean like they'll have like, you know, I don't know, it's supposed to be an 8 millimeter bolt, but it's actually undersized. They're usually like 7.89 to like 7.95 or something. It varies.
Yeah.
And then they'll have like a 8.1 millimeter or like a 8.05 millimeter hole. And to me, I'm like, that bolt like kind of fits loose, but obviously when you tighten everything down, it like cinches together. But that's a big reason why a lot of bikes creak is like they create way too much clearance, and then there's like movement between stuff. And obviously you can't have everything be ultra tight because it might be difficult to install, you know, a pivot bolt when you're trying to feed it through. But you can have it be tighter than that if you have more control. So that was like one thing. And there's certain things that I've made and it's been too tight where you're like, okay, we actually need to run a precision reamer through this after to make it a little bit bigger, because that's just not enough clearance, especially when you start to get into like anodizing. Anodizing adds dimension to aluminum.
Yeah.
You know, it's a super small amount. It could be around 0.01 of a millimeter or so per surface, depending upon what you do. And, you know, powder coat too. The distortion from welding will also change. Well, that'll mostly change like the shape of a hole. And then, you know, that's the nice thing is I kind of create, I'm not like, obviously it'd be really nice to be able to just pay somebody else to make the bikes. So that I could maybe focus on more the business side of it. But making every bike, I get to be that person. I get to be, you know, it kind of takes me back to the bike shop where I'm looking at stuff and I'm picking it apart and can this be better? And yeah, like luckily, most of the decisions that I've made have not like backfired. Like we've got the tolerances in a really good spot, and they can always, I'm constantly refining and learning about where I can be tighter with the tolerances or looser and still have a really good quality of the bike and really good accuracy of it. Because again, it comes back, it needs to be as accurate as possible to ride the way that it's designed. So
definitely. Yeah. And you mentioned the business side of it, which you have to move on to, I guess, like the engineering at some point has to stop and you have to focus on selling the things. A big part of that is the marketing side. And you've got an awesome project this year that was announced pretty recently, which is going to massively help get the brand name and the bikes in front of more people. And so you're supporting Anna Newkirk and Abby Hoagie with their Beyond Racing team, and you've been creating some custom downhill bikes for them that they're going to be racing at the World Cups and beyond this season. Tell us a little bit about how that came together and how it's going so far, because it's an awesome project.
Yeah, that I'm super stoked to be honest, but that I didn't think that I would be able to get a bike like out into the world in that way, like be able to support a World Cup, a UCI World Cup team. And I basically, I guess I'll rewind back just a little bit to my wife. She started her own sports bra company as like a side project. Like she actually works at Giro Cycling doing their apparel. But she also started this sports bra company called Loom 6. And in the long term, I was like, I really want to have a Contra Loom 6 team someday. That's all these women. Like I remember the Luna chicks, like back in the day was Santa Cruz bicycles and like Luna bars or whatever. And that had a huge presence. And I was like, I feel like women are not as supported. I mean, I don't know the actual like financial backstory or like background, but I think women are not as supported in the sport. And so I felt like there was more of an opportunity there for me to help somebody. And watching them, Anna and Abby, progress, like seeing them race the World Cups, and they started their own team, and they're both on the up, like, you know, and I think they're on the verge of some really great results. And I think that what they're doing is cool. I kind of vibe with that, because like I was a privateer trying to make it work. So yeah, out of the blue, I think I sent them an email, and I remember just being like overconfident and just being like, yeah, I can, like, basically just being like, yeah, I make these bikes, and you know, it could help you, you know, it's going to be an amazing bike that could help you. Like, I hadn't even created this bike yet, and I'm basically just selling it to them. Like, I can make this bike that will help you in the World Cup. And I'd be more than happy to, like, basically just throwing it out there. And I also was like, you know, I can't, other than providing bikes, like, I won't be able to provide like financial support, but I do have a lot of connections in the industry, and I could help find support. And I just didn't hear anything. Like, I sent that email, I think it was an email, and I didn't hear anything. And it was like a week or two, and I reached out to Elliot Jackson. I'm sure you obviously know Elliot, and he started Grow Cycling, and that was one of their sponsors or supporters on their jersey, was Grow Cycling. And so I like messaged him or texted him and was like, hey, you know, I sent them this thing and I haven't heard back, like, what's going on? And he's like, I think he said something like, just, oh yeah, no, they know, they're going to get back to you. And I was just like, okay, whatever. Like, I didn't think anything was going to happen. And then they were like, yeah, we're like super interested, but like, we got to wait and see what's happening with our existing sponsors and blah, 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 blah. And I was like, okay, whatever. They're probably going to, you know, get money from somebody, and that'll be the way that they go. And, yeah, then it just ended up being, they're like, yeah, let's have the conversation and see what's going to happen. And, a huge part of it happening was, my wife's connection at Giro, and my connection at Giro as well, because she's been working there for like 8 years. And we knew all the marketing people there, the sports marketing. Jim Heaney and Dane Zafke are, you know, friends and people that we see regularly. And I was like, I'm going to tell them about these girls and see if they're willing to support it, because I think it'd be awesome to have like Giro and Contra and whatever. I feel like it would really fit with their brand. So I had a conversation with them, and they seemed super into it, but I didn't know where that would go. And luckily it went the right direction, where they ended up making an offer that the girls were willing to take. And it allowed for me to be able to just be the one providing frames, which is a huge expense for me to create frames. And even just the cost of one frame is a lot. But like, you know, they could probably get bikes from whoever maybe not whoever, but they have good results. They have good exposure. And I was just super stoked that they were willing to take a huge chance on me making a bike for them, you know, a bike that didn't even exist, hadn't been designed, and me just being like, yeah, it's going to be great. It's going to be amazing. And it's going to help you go faster. And so when they did push go, it was like, it was a bit nerve wracking, because, you know, I'm trying to make the production bikes, and then I'm like in the background, oh, I have to completely design this downhill bike and figure out how I'm going to make it. And it's not just the same. It's not, the downhill bike that I ended up making is not just the trail bike with like a different shock or whatever. It does use all of the same exact linkages. That was something that I wanted to try to do, because the cost of making those parts over again is quite expensive. But yeah, it basically repositions everything and creates the kinematics. Like, it's 98% of the performance of what I would make if I had just an open book and like could make whatever. And so and I didn't know that I could do that until I explored it for a very long time on linkage to figure out how to do it. But yeah, it's been awesome. Creating that bike. That's also something that I wanted to make. It just kind of sped up the process of, I do want to make a downhill bike at some point. I know that that's not what downhill bikes aren't what sell, but it's what I did. It's what I raced, and I want to have a downhill bike to ride. And I think the platform, like the suspension design, is very well suited to a downhill bike. So yeah, it just sped up the process, and I can't wait till I can get some time to make one for myself too, you know. That'll be amazing.
Yeah, for sure. Yeah, making the first bikes and having to let someone else have them it must be challenging. How are Anna and Abby getting on the bikes? What's the feedback been like?
Yeah, so that was definitely nerve-wracking. At first, I was just creating the bike based off of their feedback, you know, like other bikes that they had ridden. And I just had to kind of guess, you know, they're both a similar height. I think they're around 5'5" or 5'6". Similar weights between the two. So that really helped because I didn't have to be making like one really big bike and one really small bike. Like they're both riding the same size bike. But also like, I know that, you know, the kinematics work well on my trail bike. I didn't know that with the downhill bike. I thought that it should. I've done all my homework. And they got on the bike. The first day they were on the bike, it was super muddy. We did downhill shuttle laps, and so that's the other thing too, is they're American, but they both live in Europe, which is probably a really good setup for the World Cups. But so they actually committed to flying out here and spending quite a bit of time out here. So they flew out in, I think it was the beginning of March, and started testing the downhill bike. But we had horrendous weather. So the first ride was in the mud, pouring rain. And within 2 runs, they were like, I'm already comfortable on the bike. Like I'm already feel comfortable. And they're like, that says a lot. And I'm like, I don't know. Are they just like saying that because they want to say that this is the right decision, or they want to make me feel better or whatever? And very quickly, it was clear that they were comfortable on the bike, that they were adapting to the bike very quickly and going fast, like right away. And so for me, that was really rewarding. And then even more rewarding than that is that they have ridden the bike a whole bunch more. And I keep asking them, I'm like, okay, well, we have to make you a second. Part of the deal is they're each going to have 2 downhill bikes and a trail bike, and 2 downhill bikes because obviously, like, if something goes wrong, like I do all my homework, but if something goes wrong, you got to have a backup. And also because the racing now is so condensed, like having 2 bikes at the races is much better than 1. So if something does go wrong, even if something goes wrong with a component of their bike and they can't fix it in time, they can just grab a spare bike. Because I don't think they had that with their prior sponsor. They were riding on one-off bikes, and if something went wrong, that was all they had. So yeah, they've ridden them more. They went and did their first downhill race on them up at Port Angeles, which is in Washington. And that was also really nerve-wracking because I'm like, I don't know, they've been riding them, but like, what's it going to be like when they go and race them? Is it going to be good? And it was good. Anna ended up winning the race there by like almost 9 seconds in the pro women's field, and Abby ended up getting on the podium in 5th. So I know it's not a World Cup or anything, but that's their first race experience, is both being on the podium, and Anna winning the race by a lot was like, I was like, yeah, that's great. And then since then I've asked them too, I've been like, so for the next bikes, because I'm going to have to make those before the World Cup in June, I'm like, what is there anything that you want to change? And they're like thinking about it. They're like, no, like the bike is super good. Like we're not, and usually you'd think they'd be like, oh, I want 5 millimeter longer reach, or I want a slacker head angle, or I want a different kinematic, or I want a different chain stay length, or whatever. And they're just like, no, we just want the same bike. And this is like, which makes me feel good because I definitely spent a lot of time poring over every detail to try to make it the best that I possibly could for them. I basically built the bike for them. And then, the benefit is that I'll also get to ride one eventually when I make a bigger one. So,
yeah. Awesome. A good start, man. That's good to hear. I'm looking forward to seeing how they go this season because they're exciting races anyway, but it's cool to see them on something a bit different. So, yeah, congratulations on pulling that together. We should start wrapping up. We've got our final 4 questions that we've asked most people.
Yeah.
The first one of those, if our listeners had £150, which is about $185 to improve their performance on a bike, what would you personally recommend they go and spend it on?
Well, if they have to spend it on like a component or something, well, there's a few different things. That's hard. I mean, suspension service is a good one. If your fork or shock is tired, maybe most people might not realize it, but like a fresh fork service is pretty noticeable. The other thing that improves your performance that you could spend it on is just having fun. So like taking that 150 pounds and going on a road trip with friends to go ride a new riding spot or like go do a lift access day. So yeah, I would say either if you got to spend it on some sort of component, get your suspension serviced, or at least like the fork, because that's probably going to be the most noticeable. Or go on a trip, a small trip. Like obviously you can't afford to go somewhere super fancy, but you can go ride with your friends, because having fun and riding new spots is probably, I think, one of the best ways to improve your performance on a bike is riding somewhere new. So
100%. Yeah, I like that. Good stuff. All right, second one. If you could wind back the clock and sit down with yourself age 16, what advice would you give him?
Probably to just be more of a professional when you're racing, on the marketing, like focus on the relationships that you could make with sponsors, because I think I was just so focused on trying to achieve a certain result or get faster that I was not creating the best relationships with sponsors, and I probably could have maybe I would have gotten farther in racing if I was able to balance that a bit more. But also, the other thing that would have been really cool is like to have started playing around with this stuff when I was younger, because it would have been cool to, I don't know if I would have been able to make a bike when I was younger necessarily, but it would have been cool to have started playing around with welding, like learning how to do that, or learning how to machine stuff a little better. So I guess those would be the two. If only one thing, it would be probably the relationships with sponsors.
It's something you learn as you get older, I guess.
Yeah.
But yeah, good advice. All right, next one. If you could have a coaching session from anyone, past or present, who would it be, and what would you want to learn from them?
It would probably be Nico Vulio, and I would. I don't know. I mean, he knows so much. Like he's won everything. It would probably be. Well, I guess that's tough. Because the other thing is like you think about Sam Hill and cornering, like that's such a big part of his thing. Nico, it's like everything. Like he's good at everything. So I don't know. It's hard to be like, teach me how to be good at everything. So Yeah, maybe we would change it to Sam Hill then, and just have a cornering lesson from him, because I feel like that would be pretty fun.
Both would be good days for sure. Yeah, nice one. All right, last one. What do you do every day that you feel benefits you?
Drink coffee. No,
Okay.
I mean,
how you keep
no,
going?
probably drinking water, to be honest, would be something that would benefit me. But also, I don't do it every day. I wish I could do it every day. Is ride my bike, because
Yeah.
it's so easy to get wrapped up just you know, making bike frames or designing things. And when I get out on my bike, that's when I'm happiest for sure. It's definitely yeah, but drinking water is probably the best thing you could do.
All right,
Yeah.
good stuff. If well, before we wrap up, you should just give us a bit of a summary of where because it's the Contra MC,
Yeah.
right? That's the name
Yeah.
of the bike. Just give us like an overall summary of it, like travel,
Yeah.
some of the headline figures and stuff, so people know what it is we've been covering, because we haven't gone into the detail of the bike particularly.
Yeah. So the bike that I'm selling currently is called the Contra MC, which kind of stands for Magic Carpet, because that's how I feel like it rides. Which is funny because there's a trail here called Magic Carpet, and it's not really that great of a trail, and I didn't name it after the trail. But yeah, basically the bike is kind of it's definitely a longer travel enduro bike. So the travel varies. On the smallest frame size, it's actually 160. On the biggest frame size, it's 166 millimeters of travel.
Okay.
170 millimeter fork, pretty slack head angle, like 63.5 degrees, steep seat tube angle. It's basically a climbable downhill bike. The bike pedals really efficiently, which is something that maybe people wouldn't think. But most people that get on the bike and go and climb it, they're like, even though it's quite a heavy bike because it's made out of steel, and I didn't push the limits with tubing or whatever, it climbs extremely well. So it's kind of the bike where you can climb up anything, you can do a big day on it, but it's happiest when it's steep and rough and fast, and the rougher and steeper and faster it gets, the better it works. So that's kind of the direction I went with that bike. And it does actually still jump quite good too. That was something that the feedback that I've gotten is the bike jumps really well, and that's something that maybe isn't usually a characteristic of a high pivot bike with a lot of travel. So yeah, I would say if you want a bike that you could go and you could actually, like, you could take this bike and go and ride Whistler Bike Park in it, like, no problem. And climb it, huge amounts of elevation. Yeah, it does way more, but so that's kind of the intended use of it. You could also go out and race enduros on it. It's not the lightest bike. I wouldn't ride it on a flatter enduro. Like, it's not going to be fun on something where you need to just be pumping and sprinting and carrying speed. But if you like going fast, you like riding steep stuff, you like hitting big jumps, or you don't have to hit big jumps, but if you do, it'll do all that. It'll handle all that, and it'll, I think it does it extremely well, but I'm obviously biased. But yeah, and then I do want to eventually sell the downhill bike once we've tested it a bit more. I think that is probably the next thing that would be available, would be making that available to whoever wants to buy it, because it does use all the same linkages. So it's basically, it uses an entirely different jig, but yeah. So right now,
Awesome.
big travel bikes. I would like to make a short travel someday. That's definitely one of the next things on the list too. So
cool. And what's the website for the bike?
yeah, it's just contrabikes.com. Yeah.
CONTRA. Yeah.
Yeah.
Perfect. And same on Instagram?
Yeah, it's at Contra Bikes, but there's literally, I'm not good at social media. Maybe I should care more about that, but yeah, there's literally like 6 or 7 posts over the last like 2 years. So people think I'm probably don't exist. But I'm just focused on other things, and I will in the future want to create some more content for people, because people do want to see like how these frames are made, and you know, see. I'd love to do more stuff with the Beyond Racing team, the Anna Newkirk and Abby Hoagie, and create some more videos and stuff for people to watch. I think that'd be cool.
Yeah, definitely, man. Well, I'll stick links to those in the show notes so people can find them. Yeah, I'm looking forward to seeing how it goes. Hopefully seeing some Contra Bikes over here in the UK. Looking forward to seeing how Anna and Abby get on the World Cup circuit. But yeah, thanks for your time. It's been super interesting, and I wish you all the best of luck.
Thanks. Yeah, thanks for having me on. It was super fun.